Today, we're not just talking about writing code. Nope. We are talking about building digital fortresses. We're going to look at the actual blueprint for making software that's strong, reliable, and secure, right from the ground up. I mean, this is the critical question of our time, right? Every single day, we're trusting apps with our most private information. So how do we make sure that software is a vault and not, a sieve? That's exactly what we're about to dive into. All right, here's our game plan. First, we'll get into why this is so important. Then we'll break down the 6 foundational principles of security. After that, we'll see how you actually weave security into the building process. Look at some of the secret weapons developers use, and wrap up with the real-world payoff for getting this right. Let's start with the big picture. You have to imagine the modern internet as this huge digital battlefield. Your data, it's under constant attack from all sides. And building secure software, that's our best and really our first line of defense. When you really boil it all down, secure architecture has 2 main goals. First, you've got to protect the data itself. Keep it safe from being stolen or messed with. And second, you want to shrink the attack surface, basically reducing the number of weak spots a hacker could try to break through. And this isn't some abstract concept. Think about it for a second. A single flaw in a hospital's software could leak your most private health records to the world. A tiny weakness in your banking app, it could literally drain your account. The stakes are unbelievably high, which is why having that strong foundation it's not optional. So how do we build that strong foundation? Well, it all starts with a solid blueprint. And in the software world, that blueprint is made up of 6 core security principles. These are the very bedrock of our defense. The whole philosophy here is something called secure by design. What that really means is that security isn't just something you bolt on at the end, like an afterthought. It has to be a fundamental part of the plan from the very first sketch, a core feature, just like anything else. First up is confidentiality. This one's pretty simple. Your data should be a secret. It should only be accessible to people who have permission to see it. Think of it like a sealed letter. Only the person it's addressed to should be able to open it and read it. Next up, integrity. This principle is all about making sure the data is trustworthy, that it hasn't been tampered with. This is kind of like the wax seal on that letter. It's the proof that the message inside hasn't been changed on its journey to you. Then we've got availability. I mean, a fortress is pretty useless if the people who are supposed to be inside can't get in, right? This principle makes sure the system is up and running when you actually need it. Simple as that. All right, authentication. This is the process of proving you are who you say you are. It's the guard at the gate yelling, "Who goes there?" and demanding your ID. In your life, this is your password, your fingerprint, or your face unlocking your phone. Now, once you're authenticated, authorization takes over. This is what defines what you're actually allowed to do. Just because you have a key to get in the front door of the building doesn't mean you can waltz into the CEO's office. That's authorization, setting your level of access. And finally, accountability. This means every important action is logged and can be traced back to a specific user. It's the digital paper trail. Think of it like a security camera system that records who went into which room and exactly when they did it. Okay, so we have our blueprint, those 6 core principles. But a blueprint is just a plan. Now we need a disciplined method for the actual construction, a process for building security right into the software itself. This is where the Secure Software Development Lifecycle, or SDLC, comes in. And this diagram, it perfectly shows that secure by design idea we talked about. See how it's a continuous loop? Security is a thought at every single one of these stages, from figuring out what to build, all the way to maintaining it for years. So the most crucial thing to get here is this. Security becomes a built-in part of the process. It's not some final check before you launch. It's a thread that's woven into the very fabric of the software from the absolute beginning. Now, to actually execute this plan, developers need a really powerful arsenal of tools and techniques. These are the secret weapons they use to build and defend that digital fortress. A huge one, a real cornerstone of this arsenal, is cryptography. At its heart, it's the science of creating secret codes to protect information. It's what turns your normal, readable data into scrambled, unreadable gobbledygook. Now, cryptography comes in 2 main flavors. You've got symmetric, which is like a simple house key. The very same key locks and unlocks the door. It's fast, it's simple. Then you have asymmetric, which is more like a mail slot on your front door. Anyone can drop a letter in through the public slot, but only you, with your private key, can open the door and get the mail. It's a bit slower, but way more secure for sending things over the internet. So how do you find the weak spots? Well, you test for them. SAST, or static testing, is like checking the fortress blueprints for design flaws before you even lay a single stone. DAST, dynamic testing, is what happens after it's built. You're actively trying to break in, kicking the walls, and stress testing everything to see if it holds up against a real attack. So we've covered the principles, the process, and the tools. But what's the actual payoff? Why does all this matter? Let's connect this back to why it's so incredibly valuable, not just for businesses, but for all of us as users. Well, for any business, the benefits are just huge. It means you get better, more reliable products. It creates more organized workflows because you're planning for security instead of just reacting to disasters. And that means developers can spend their time building cool new features instead of constantly putting out fires. And really, it lets businesses safely connect with everyone they need to. But at the end of the day, it really all comes down to this one simple idea. Building secure software, it isn't just a technical thing about preventing attacks. It's the fundamental way that companies build and maintain trust with us, their users. So I'll leave you with this thought. Security is a continuous process, not a product you can just buy off a shelf. It takes constant work. So as you go about your day, think about the digital tools you rely on and ask yourself, what's the weakest link in your digital fortress?